All right, so you guys probably don't realize this, but there is a polar mode in your calculator. So I think the only time you've ever changed the mode in your calculator is in geometry when you're going back and forth between radians and degrees. But there are a lot of modes that you can change in your calculator. So go ahead and hit mode. If you have one of the yellow calculators, this may already be changed, but it may not. We'll see. All right, so this is what pops up. If you have a more updated calculator, it looks somewhat different. But up until today, everything you've ever graphed has been in function mode. We're going to go down there to function mode, and we're going to change to polar. So hit enter on it. And then now, when you hit y equals, it is not y equals, it is r equals. I know, it's so cool. All right, so what we're going to do is type in this function, which is r equals 5 sine of 2 theta. R is already there. It says r equals. What you don't know is where it is theta. It is. So if you look at what you normally click to hit x, it says xt theta n. Well, when you're in polar mode, when you hit that button, it is theta instead of x. All right, we're not going to go to the graph quite yet. You can if you want to, but we're going to hold off, and we're going to go to the table. But before we do, I want to make sure the table is the table that we need. Bless you. And so what you're going to do is go to table set. You only have to do this one time. So table set is second window. All right. So, I need to change some stuff on this too. We're going to have our start be at 0. So if yours doesn't have 0 there, change it to 0. And then our change is going to be pi over 12. So we're going to change that to pi over 12. Because that's what I want it to be. That's going to fill in our table, and that's just going to be typically where things change. Yes?
I apologize. I'm looking at it. How do you get the table set up again?
It's second and then window.
What do you put?
Second.
5 or what?
12. Pi over 12 is what we want it to be. And both those need to be on auto. I had mine on ask. Yours is probably on auto. It says calculators have been reset. All right, everybody good? Okay. All right, so now we're going to go to the table. So table is second and then graph. All right, and then double check that your thetas are the same thetas that are in this table. If they're not, then let me know and I'll see if we can fix it. You may have to scroll up or down. All right, if yours are, go ahead and start filling in the R values. If you round, go to 3 decimals. Look at it. You have eyes. Okay, then go back to table set.
You get the same number as us.
And now go. All right, if you get something that's like negative 1e to the negative 12, do y'all know what that means? It's scientific notation for zero. So it's like negative point and then 11 zeros and then a 1. So that just means zero. The calculator does that sometimes.
Just really goes to zero. Just like force 56. Don't care if it's zero.
All right, you guys good? Some people are still filling in their table. It's okay. All right, what we're going to do next is block off sections of the table where R is positive and R is negative. So in this first column that I have, that's what we're going to do. So we start off with 0, which isn't positive or negative, so we're just going to kind of do it in the middle of that, all the way to that 0 is going to be positive. All right, 0 to 0. Again, this time is going to be negative. All right, the next thing we're going to do is block off sections on the table. Oh, sorry, let me move over. Okay, block off sections on the table where R is increasing or decreasing. All right, so I start off with 0, it goes to 2.5, that's increasing, 4.3, still increasing, 5, increasing. After 5, it starts decreasing. So from 0 to where we get the point B, that's going to be increasing. All right, and then 5 all the way to negative 5, where the R is 5 to negative 5, that's going to be decreasing. Those R values are just getting smaller, smaller, and smaller. All right, and finally, we are going to watch the graph get graphed. So I've been talking a lot about the order that things happen. So I want you to watch it. And so what I'm going to have you guys do is hit zoom and then zoom square. Gives you a square window where it looks more proportional to the way it's supposed to look. So hit zoom and then 5.
I've already forgotten.
Uh-oh. I don't know what just happened. All right, zoom. What is happening? I haven't. It's like hitting it double or something. There we go. It happened really fast. I didn't really even see it. Did you guys watch yours graph? Okay. And so where did it start? Did you notice? At 0, 0, right? At 0, 0, that's going to be point A. All right. And the order it graphed was A, and then it went to B. And then it went back to A. And then it went to C. That's down here. Oh, sorry. I need to start over. All right. So we started at A. We went to B. Back to A. And then to C. And then back to A. And then D. And back to A. And then finally E. And then back to A. So that's the order that it was graphed. So if it's a calculator question, you can see that order. All right. And then the last thing we're going to do is determine if the distance between the graph and the origin is increasing and decreasing. That is a different question as is R increasing or decreasing. So as you're moving away from A to get to B, is that distance between A and the graph increasing or decreasing? Increasing. So all the way from A to B, which is here to here, it's kind of hard to see. The distance between the origin and the graph is increasing. All right, and then we're at B and we're gonna go to A. What do you notice about the distance there? Decreasing. So if we're going towards A, that distance is decreasing. If we're going away from A, that distance is increasing. Bless you. All right, so I'm showing you guys all this. So maybe we can find a pattern that even if we can't have a calculator, we can still figure this out. Or if we do have a calculator, we can still figure it out. So I noticed that this little section of increasing, the R is positive and also increasing. All right, my next section of increasing, the R is negative and decreasing. All right, no coincidence. That happens again over and over and over. All right, this first section of decreasing, R is positive and decreasing. All right, this section of decreasing, R is negative and increasing. Okay, so let's flip over on the back. All right, so it's the way I think of it is if the R is positive and increasing, they're like working together, and that distance is getting bigger and bigger and bigger. Also, if R is negative and decreasing, it's also working together, and that distance is getting bigger and bigger and bigger. So if R is positive and increasing, and Or if r is negative and decreasing, that distance is increasing. But if they're working against each other, that distance is getting smaller. So positive r that's decreasing or a negative r that's increasing means the distance is going to be decreasing. They're working against each other. Okay, so we're going to do a couple of examples where we're going to find all the intervals of increasing and all the intervals of decreasing. And we're going to let our calculator do the work. We're just going to need to know the rules from that table. All right, so we're going to do the graph of 3 plus 6 sine of theta. What is that going to be a graph of? The French word, right? Limachon. Is it going to be an inner loop? Is it going to be a clam? Is it going to be a heart? Loop. Less loop. All right, so let's type it in. All right, if you want to look at the graph before we answer these questions, it's kind of cool. There it is. But what we really need is the table. Bless you. All right, so this whole table right now, r is positive.
Where do we start?
0. So, sorry, this is from 0 to 2 pi, so we're going to start at 0. And we're finding all the intervals which the distance between the origin and r are increasing and where they're decreasing. So it's that last column that we did on the front. Okay, so all positive. Would you say these r's are increasing or decreasing? Increasing. Let me go down one. All right, then they start decreasing. So from 0. So positive increasing means that distance is increasing from 0 to 1.571. All right, and I know it's going to change over to decreasing at that 1.571. Let's see how long it's going to be decreasing. All right, so it looks like we're going to be positive, decreasing all the way to 3.665. And then R changes to negative and decreasing. So hold on. All right, so at 3.665, R is negative, but it's still getting smaller, smaller, smaller until we get to what number?
5.7.
Yeah, the 4 point.
Yeah.
Just one point right here when R is negative 3, then R starts increasing. It's okay. So that was 4.712. All right, so then I know we're going to have a change. All right, so at 4.712, R is negative, but it starts increasing until we get to 5.7. 5.60 or 5.7596, however you want to write it. All right, and then we're switching back to increasing there. And remember, we're only going to 2 pi. So what is 2 pi as a decimal-ish? 6.28. So as a decimal-ish, pi is 3.14, so 2 pi should be 6.28. All right, there it is. So we increase all the way. I mean, it does keep increasing, but we're only going to 2 pi. All right, any questions on that? Y'all want to try one on your own? Okay, why don't you guys try example 2 on your own? Finding where the distance between R and the origin is increasing and where it's decreasing.
It's not the value.
Not the value, it's the distance. So you're looking at what's going on basically in the table. Okay, he's on his way. Oh, sorry, Derek. This one is just 0 to pi. I didn't say that, but this one is only 0 to pi. So if it's taking you forever, it's because you're going farther than you want to. So you can stop at 3.14 on this one. Sorry. Um,
That would be what I'm lost. Okay, I was like, wait a minute. Okay.
all right, so this one should be a rose. You could look at it, but it's basically this graph right here. All right, any questions on that? Okay. All right, and then the last one, and I kind of like these questions. You don't need your calculator for it. You just know kind of where R is positive and negative, where R is increasing and decreasing, and you decide the distance between R and the origin is increasing or decreasing. So you guys fill in that table on your own using the rule. All right, so tomorrow we'll do some of the similar things without a calculator. So I went through 3 practice tests and there was about 12 questions. Only 2 were on the calculator portion of the exam. So you're going to have to know how to do a lot of things without the calculator. But the multiple choice questions will be written in a way where you don't have to plug in every single number. So don't get too stressed. It'll be fine.